This is a question I always ask when I run workshops. Just imagine an adversary has the credentials for one of your customers. How are you going to defend against that in your system? And particularly when we're talking about social engineering, this is the assumption that we have to start to work on. So we've looked at lots of different ways throughout this course where an attacker may get someone's username and password. So they may use human-based social engineering and extract it from them over the phone. They may get it from a data breach. There are a number of different ways that this can happen, and we need to think about how we build systems that are resilient to it. With that in mind, let's have a look at multi-step and side channel identity verification. Now, all of this is about what I just mentioned, designing the system with the expectation that the people will be compromised. The people, of course, usually being your customers. Now, when we work on the assumption that those people are going to be socially engineered, we have to start thinking about controls that are much harder to socially engineer. Now, those controls may be technical, they may even be social, and I'll give you examples of each in just a moment. But we also have to think about how do we design it to minimize the usability impact. Because one thing that we all need to be very conscious of is that often security is implemented at the cost of usability. And we have to find a good balance such that we keep systems secure, but we also keep customers happy, because ultimately the systems are there to serve the customers. Now, further to that, we also have to acknowledge that nothing is going to be foolproof. And we have to recognize that there is going to be a balance. How do we make it secure enough whilst remaining usable enough? So let's go and have a look at ways of doing multi-step and side channel identity verification. And then I'm also going to show you how it can be circumvented as well. When we talk about multi-step verification, we're talking about requiring more than just a username and password. Now, this is also often referred to as two-factor authentication, or 2FA. But that term can be a little bit misleading insofar as it implies that one factor is something that you know, which is usually your username and password, and the second factor is most commonly something that you have, such as your mobile phone where you can receive an SMS. The problem is that in a very mobile-centric era, often everything is in the same place. Multi-step is a technically more accurate way of describing this. Now, what we're looking at here is a perfect example. In order for me to log on to my Coinbase account, I need my username and password, plus I need to have access to a token generated by an authenticator app. Now, that token rotates every 20 seconds. The value that you saw here had a very, very small window of usefulness. So in order to use this, I would have had to have logged on, gone to my authenticator app, and then entered this token before the countdown expired. It's got 12 seconds there until that one expires. If it expired too soon, then I'd need to use the next token instead. So the idea is to limit the window of opportunity for which the token is valid. Now, implementing multi-step verification can be very easy these days. So for example, by using Authy. This is what the Authy app looks like when you set up a new application, and it's simply a matter of pointing your smartphone at a QR code on the screen, which sets it up uniquely for your account. Now, as a technology professional implementing this technology, it can be a very simple exercise. Multi-step verification tools like Authy are designed to be easily implemented into just about any application. So these days it can be quite easy to set up multi-step verification, and it's a great way of dealing with that scenario that I posed earlier on, the one where the adversary already knows the victim's username and password. In terms of the usability aspect of this though, there are different levels to which it can be implemented. Let me give you an example. Earlier on, I fired up an incognito session of Facebook and logged onto my account. Because it was incognito, Facebook hadn't seen me using that client before. So it said, hey, we haven't seen you authenticated as Troy Hunt before. We'd like you to enter the unique 6-digit code which the Facebook app on my iPhone generated. Now I like this because normally it's a once-off for the browser. It's not going to challenge me for the code every single time I come back to Facebook. But this is something that the designers of the system can decide for themselves. In this case, I can keep coming back to Facebook and providing a legitimate username and password, and because this specific browser has seen me successfully demonstrate that I have access to the code generator before, it won't prompt me for another code. Alternatively, if it was, say, a banking system, you might say, even if I've seen this person before and they've successfully logged on using this client and using their second step of verification, I'm going to challenge them again because I want to have a higher degree of confidence that they're a legitimate user. There's more at risk. It's a bank. And not only is there more at risk, but you're less likely to keep coming back to it every day like people tend to do with Facebook. So the point here is consider how to use multi-step verification in a conditional way. You can reduce the usability barrier for the right systems by choosing when the user should be challenged for that code. Let's go and look at something a little bit different, and that's side channel verification. Recently, I added my American Express card to Apple Pay so that I could use my iPhone to pay at terminals that supported it. Now, after I set that up, I got the email that you see here, and there's something that I particularly like about the way this is worded. It's this section just here. Now, this actually goes back to one of the scenarios I explained earlier on. The sort of email that you see here, one that comes from a financial institution, is the sort of email which is often a phishing attack. And what I like about the approach that I've highlighted here is it said, hey, if this wasn't you, call us. But we're not going to give you the number. We're not going to tell you how to come back to us. You can go and use an entirely different channel of verification, which is to pick up your card, turn it over, and then phone us on the number on the back of the card. So in this case, the card itself becomes a side channel. It's a different channel to the way we've received this email. This is a good way of doing verification because it means that an adversary has to actually compromise the other channel as well. They'd have to actually change the number on my card, which clearly isn't going to happen. Now, as good as multi-step verification and this sort of side channel verification are, as with anything, there remain risks. Let me show you what I mean. This is a great story around how two-factor authentication, or as we've been referring to it, multi-step verification, could be circumvented by some clever engineering. In this example, the attackers contacted the victims with a phishing SMS. Now that SMS directed them to log on to the attacker's phishing page, which was made up to look like Google's. The victim would enter their Google username and Google password, after which they would see a challenge from the attacker asking for the code which had been SMSed to them. Now what the attackers would do would quickly take those credentials and attempt to log into Google, which would then generate a legitimate SMS to the victim, who would then go and enter it into the phishing page of the attacker. The attacker would then take that code and log on to the victim's actual Google page. So effectively, the attacker was socially engineering the victim into providing their code. Now this is a really time-critical exercise because as we just saw in the Authy example, those codes have a really limited lifespan. So they would have had a very high rate of failure with this, but they still managed to successfully socially engineer some victims. Now I show you this simply to point out that even very well-designed systems, such as two-factor authentication or multi-step verification if you like, can still be circumvented. It takes a lot of effort, it significantly raises the bar, but it's not foolproof. Let's now move on and look at another way we can minimize the risk of social engineering, and that's using logging, auditing, and monitoring.